Good morning, all. Thank you very much for joining today's webinar presented by NeilSoft for BIM Process Automation. My name is Dhananjay Dixit. I'm associated with NeilSoft for about 20 years, primarily looking after design automation and BIM process automation using AutoCAD, Revit, Navisworks, and other softwares. And that is where today I would be presenting on BIM process automation and some of the items that or subtopics which I would be covering in today's webinar are how NeilSoft can help to standardize your process when you are adopting BIM, or if you have already adopted BIM, how we can make sure that there's a standardized process implemented within your organization. At the same time, how we can make sure that as the process is being utilized, how we can make sure that the quality and the consistency is maintained across the BIM implementation that has happened. Also, as part of the BIM implementation, it doesn't remain at just doing modeling, but how effectively we can make use of automation capabilities to automate your repetitive tasks or your design calculations or generation of various reports and so on, or integrating your BIM data with third-party systems like your ERP systems or asset management or facility management systems. And of course, integration with some of the existing softwares, which I'm sure a few of you are already using, like BIM 360 or Autodesk Forge. And as the design moves from your 3D to 4D, 5D, and 6D, then how we can really do quantity estimations, cost calculations, construction scheduling, and so on, and how automation would help there. So I would like to take this opportunity and start with this webinar now. I would be taking questions towards end of this towards end of this webinar, but please feel free to put your questions in the chat box, which is there. Also, you can ask your questions through the questions box, which is there on your GoToMeeting screen. So to start with, NeilSoft, at NeilSoft, BIM, the building information modeling, is a methodology or workflow which we adopt or implement for multidisciplinary, multi-platform, multi-location, or multi-sectoral projects across various domains such as buildings, infrastructure, plant, and so on. So in buildings, be it architecture model, structural model, or M model, that's where we have extensive experience serving customers based out of Europe as well as US, where not just contributing for the BIM, but essentially establishing the standard processes, quality checks, Revit content and the content management for entire building system. That is where we have contributed heavily. We have extensive experience. At the same time, when it comes to infrastructure like road, tunnels, or your metro stations or railway infrastructure or airports, that's where we have executed projects internationally to implement the BIM as well as do perform BIM services across US, Europe, and few other Asia Pacific locations. And now, BIM for plants is relatively a new terminology that has arrived in the market. So far, when it comes to plant design and plant engineering, traditional approach has been to use systems like Smart Plant 3D or Aviva PDMS or Aviva Everything 3D, those kind of systems. But now, as architectural structural modeling has moved to Revit, now industry has started demanding that our plant also should be BIM enabled. And that is where for small to medium-sized plants, that is where we are seeing that Revit is widely being used, widely being adopted. And that is where for these small to medium-sized process plants like your water treatment plants or desalination plants or few other types of plants, that is where we have helped customers in Middle East and few other locations to implement BIM for plant engineering and plant design process. And this is to give you overview about the capabilities that we have when it comes to BIM implementation as a methodology or workflow within your organization, be it buildings, infrastructure, or plant-specific engineering that we want to achieve. Moving on to the next slide. As part of the BIM process standardization, NeilSoft plays a very crucial role in implementing the strategy across various stages of the project. So be it early design stage where essentially we are working on concept of the design, let's say how my building is going to look, what are the criterias, what are the specifications of the building, and that is where typically we use softwares like SketchUp, AutoCAD to essentially do the concept design. And moving on from there, we go to pre-construction, where actually we define the specifications, we define your Revit content or the families, we define the specifications, we define what kind of outputs we are going to generate, what are the different templates that we would be using, and also do the 3D modeling. So that is the within the pre-construction area. And during construction, essentially your site planning, the site management, construction sequencing, construction planning, logistics planning, clash coordination, and those are some of the areas where Neilsoft has contributed or Neilsoft has capabilities in working with various customers. And when it comes to actual construction or manufacturing, essentially giving data which is going to be required by different vendors at your site or different locations to cut the steel, or let's say some of the precast components that are required. So giving them the right data, and that's where the manufacturing and offsite coordination and planning is where we Neilsoft can assist. And finally, as the building or your model gets constructed, and then it moves from 4D, 5D to 6D, where essentially all the operations and operations and maintenance is happening. That's where connecting this your engineering data, the BIM data, to systems like asset management or facility management, and that is where essentially it would take care of your maintenance records or operational issues of the building. So Neilsoft has, as part of the BIM process standardization, has end-to-end experience right from early design stages to the operations and maintenance of the building or of the infrastructure. Now, as part of the BIM process automation, this slide I'm going to discuss about at various stages in the BIM project lifecycle, where we start early with the concept design, 2D, where essentially we work in 2D by creating various sketches or volume models using SketchUp and few other tools. Then going to the detailed design step, and from there going to the construction sequencing, cost estimation, construction sequencing, and finally operations and maintenance. That is where Neilsoft's contribution starts with, first of all, setting up your BIM process as BIM, doing the BIM process standardization. So essentially understanding your scope of BIM implementation, at what stage we are going to implement. So whether as an architect, will you be only working in 2D and 3D, or as a contractor, whether you will be working in 3D, 4D, and 5D, or as an owner and operator, whether you would like to take this entire data up to 6D, where it will actually you will be the operator as an owner and operator, you would be doing the operations and maintenance. So that is where our methodology is to first standardize your process, make sure, okay, we understand what are the different assets that you would be creating. So the assets could be the templates that we are going to create in Revit, or the Revit families, or the content that we are going to create. And that is where understanding your requirements, understanding what kind of data we want to maintain. Also, when it comes to Revit content or the families, at what stage, what kind of level of detail, or LOD, what the terminology is commonly used, is going to be required, whether we want a very detailed design or very detailed model at 3D level, or as we go to the 4D, 5D, what kind of LOD that is required. So as part of it, the next step, that is the content development and content management, where we understand what different families need to be created, what families need to be done as static models, which families need to be done as your intelligent, parametric, and smart families, where they can adapt to changes or adapt to different dimensions or different sizes as required. And that is where we have helped many customers to essentially establish the process first, that is the standardization of the process, at the same time developing the content for them. As a next step, which essentially overlaps 2D and it can go up to 6D, which is the operations and maintenance, is then essentially developing efficiency improvement tools which adhere to the processes and the standards that have already been defined as part of the BIM process standardization. And that is where, using Revit API or Dynamo, we help in developing various tools, which some of the tools are like integrating your design calculations. So uh, there are various tools that are also being used, like for electrical calculations, design criteria certifications. So various tools are being used, and that is where we help in integrating these design calculations back into Revit, so that BIM as a model is self-sufficient with all the necessary data, the calculation results, the analysis results that is required to be part of the BIM model itself. Then one of the important one of the important steps is to do design review, as many vendors or stakeholders are going to work on the model, or they are going to require the design data at various stages. That's where this review of the design, first of all sharing the model and also getting it reviewed and getting it certified, is a crucial step within this entire project lifecycle. And that is where we can help, or we have helped customers in building the cloud-based design review systems, where from Revit itself we can publish the model, get it reviewed, get the comments, and so on. Then automation of the quality checks. As we have defined the BIM standards, and the process has been defined, but with multiple people working, we have to ensure that all the outputs that get generated, all the data that is going to get generated by people working on the projects is consistent, is up to the standards that have been already defined. There are no deviations within that. And that's where automating your quality checking process is something which we can implement. We have implemented it for a few customers, where it will check the model, or it will validate the model against set of parameters, set of rules that have already been defined as part of your standardization process. And that is where it can report back to users, okay, these are the inconsistencies or deviations from what has been defined. Then as we from 3D, as we move to 4D and 5D, then essentially the next important step is construction sequencing, and that sequence, tagging it or attaching that sequence to your construction activities. And that is where various tools are being used in the industry, right from MS Project to high-end applications like Oracle Primavera. And that is where integrating your BIM data, the BIM model itself, with your construction schedule, and creating your construction sets and assigning these construction sets to various construction tasks within the schedule. It's something which, with two different systems, it becomes very difficult. But that's where the building a bridge between your BIM data and the construction schedule really helps in further quantity estimations, which are going to be required for your construction, and the cost estimations and the cost calculations that are going to happen, where we know at every stage what kind of cost that is going to be incurred and what that needs to be allocated for. Then as we move, as the construction is progressing, then integrating your model, your data, your specification sheets, performance data, and everything with your asset management or facility management systems. That is where from 5D to 6D, where essentially all the operations and maintenance records would be carried out by these systems. Or we can develop our own system, which would essentially a cloud-based system, which can help operators, owners and operators to understand, okay, what are the maintenance cycles for various equipments or various systems which are there in the building or plant or infrastructure. Then, of course, for all of this, for various stakeholders, various vendors, they require reports, they require the specifications, they require data in a specific format, or the data which is very specific to their requirement. Like electrical systems will need data or the bill of material which is very specific to their requirement for installation and planning. That's where developing tools which help in getting custom reports out of your BIM data is what we can do as part of your process efficiency improvement tools. And as this goes to operations and maintenance, then as an added thing, we essentially implementing augmented reality or virtual reality mechanism, more for the operations maintenance or for customer interfacing. It's something which we could also help in. And last, a lot of third-party tools are already available in the market, which help in collaboration, like BIM 360 or Autodesk Forge, which is a cloud-based viewer. And that is where integrating your BIM data specifications, your cost calculations, your construction schedule within BIM 360, or developing a new system altogether using Forge is what also is a part of your efficiency improvement tools. So this is the overall picture or the view of within BIM project lifecycle, what can be done as part of BIM process automation in addition to your process standardization and content development. Okay. Now, from these slides, what I'll be doing is for each of the items that we saw in the previous slide, I'll quickly take some of the examples for the automation that we have done or process standardization where we have helped different customers. I have a couple of videos which also I would like to share with you during this webinar. So as part of BIM process standardization, few things that we do is first of all setting up your templates, and as a common goal of achieving standardization, making sure all the outputs are consistent, uh, they follow a certain standard that has been defined at an organization level. That's where setting up the Revit templates or your BIM templates becomes a very crucial and critical activity. So setting up your views, sheets, different schedules, what kind of color schemes would be used, then setting up your content, the family. So I'll speak separately on families, which versions we are going to support, how we will be sharing data, what data is going to be required, who are the stakeholders, what kind of design calculations or analysis that we are going to perform. So as part of BIM standardization, essentially enabling your processes to have end-to-end benefit is what we look for. And as part of content creation or creating Revit families, that is where we essentially help in creating the guidelines for developing families, developing content, or if already there are existing families which are available, then making sure that they adhere to specific standard in terms of the parameters or the properties that have been defined, how the names have been defined, how we can categorize your families, whether they have to be developed as static parts or they have to be developed as intelligent, parametric, and smart families which can adapt to the changes that are in the model. Then what kind of shared parameters are going to be required, what kind of family templates we need to create, how we will create the container families, and so on. So that is what everything gets covered during BIM process standardization. So in this slide, you can see some few examples where we have developed families for healthcare or other MEP equipments or even furniture or plant related systems, development of families. And this is where, depending upon the type of family, the requirement, it could be a static family or it could be a smart parametric family with some intelligence built into it, like let's example of, let's say, a family for door. Then with the door, automatically there are positions which are marked as the door swing positions, so that in case of clash detection, if someone keeps any other equipment within the swing of the door, then that can be captured and though that can be reported. So that's where the content development, we have been helping customers in developing content. And while we develop this content, we also take into consideration how this content can be made, we can make it more smart or intelligent, so that can be utilized as we automate your processes. So automating maybe some of your repetitive tasks, how we can make use of some of the properties or the smart mechanisms within the families to effectively implement the automation mechanism. As part of the content development, as we are developing the families, also the content management becomes a very crucial area where, with multiple people working on the model, we want to maintain a standard of what families are being used and how people are using it, what are the parameters that are being updated, how families are being created, what kind of LOD specifications that are being used, at what stage, what type of LOD is being used. And that is where developing container files for your families, like it could be like for walls, doors, or other things, then essentially organizing family, and also developing tools which are essentially kind of tools, collaboration tools, where the users will be able to get family data from specific locations and not from other locations. And this is more to make your BIM model consistent and making sure that the standards are followed. So now with the BIM process standardization and with content development and content management, we are moving on to the efficiency improvement tools. And this is where using Revit API, Dynamo, or few other technologies, we can help in developing tools which are part of your BIM process, and they essentially help to improve your efficiency, productivity. Also, with automation, it helps in improving the quality of the overall output that are getting generated, reduce the design time, and importantly, better manage the revisions. So because of automation, if there are any changes, we can rerun with the new specifications and new parameters. And that's where it makes it very easy for improving overall the BIM implementation and effective usage of BIM as a methodology. So a couple of examples which I have here is like on the upper left hand, you can see the tool for pipe and duct hangers. So for a huge, large MEP model where there are many pipes or hangers, essentially putting these hangers manually one by one would be a really tedious work. Although it's a repetitive task, but essentially understanding the size of the pipes, the size of the duct, and that is where automation helps in essentially implementing this, where we can insert these pipe hangers or duct hangers in automated way, where within few clicks we can have hundreds of or even more hangers placed across the within the model, and we can build intelligence into it where it can recognize what is the pipe size, what is the insulation thickness, or what is the size of the duct, and based on that it can modify the hanger instance and essentially place it using design rules or specifications that are required. And that greatly reduces the design time that's required, improving the efficiency. Or the other tool I can see here, which is on the right hand top, which is the auto layout tool. So typically where we have your layouting mechanism or logic that has been built, and we have to do more like a generative design where based on a certain area we want to place the equipments or furniture items or any other items that are required, and then we can build the system where it would analyze the region where we want to build this or we have to create a layout based on the specifications, your design criterias, the minimums that are required and the maximums that one can go up to. The tool can essentially compute what can be achieved, and then it can give back to the users various options from which users can choose. And of course, then it helps in further getting the right bill of material, getting right specifications, and so on. Or other example is the one is like formwork calculation. So for columns, beams, or slabs, essentially calculating the formwork area, the area of the exposed concrete portion, is something which is not readily available in Revit. So that is where using API or Dynamo, writing scripts which essentially automate that process, and it can generate reports in Excel or in other systems to get the area of the formwork calculation. This is more for procurement or for your cost estimations or quantity estimations. It helps. And another example developed in Dynamo is for MEP. While doing the layout of pipes, ducts, it is very important for them to visualize or understand how the ceiling height is varying across the floor plan, so that they can use they can place these pipes and hangers in a optimum way. So that is where developing some small scripts which essentially help in uh, improving the efficiency or improving your workflow. It's what we can see here. We have developed such tools for different customers. Some of the tools we even make use of these tools within our BIM modeling process that we do. So I'll quickly run a couple of videos here. So starting with this pipe and duct hanger tool, which I'll run. So here, as you can see, this is system where the fire piping system is here. Many pipes, many sprinklers, and locations are there, and putting these duct pipe hangers one by one across each, calculating the distances between them, then placing it, calculating what is the pipe size, what is the insulation thickness, and so on. And then putting them is a very tedious task. Although repetitive, it's a tedious task. But that is where these are some short demonstrations that we have developed just for the webinar. As an extended tool, this can also support your inclined ceilings by calculating the right height of the rod that is going to be required for the hangers. So here you can see user simply needs to define, okay, which type of hanger needs to be used, and they can simply select a region where these pipe hangers have to be inserted. The tool will automatically calculate the sizes as are required, the distances that are required from the start, and the distances to be maintained between the pipe hangers and so on, and quickly, immediately place these hangers without any delay. So this essentially helps to improve your efficiency, also improve the accuracy. So this video now shows about the hangers, about the ducts. So again, here the duct sizes keep on varying at various locations. So every time doing it manually, while understanding the size of the duct, adjusting your family instance as per the duct and inserting it, and then doing it over a large area would take a lot of time. But automating that process where we simply define, okay, what needs to be done, just select the position where we want to insert these duct supports, and it would immediately add those. Right. Okay, I'll now move on to the next video, which is for the auto layout. So here you can see there's a region surrounded by walls, and there's a specific location where there's a door. It could be entry or exit door, and there's a specific specification in which, okay, what for specific equipment, how much it should be there, or how the minimum number of the units should be there within the boundary. And that is where this essentially tool helps in understanding or analyzing the boundary that has been defined. Then based on that, it will make sure that all the equipments are arranged taking into consideration various design specifications or safety and other specifications that are required. Like one example is the distance or the width of the aisle width that needs to be maintained, or the distance to be maintained from wall, or minimum distance that needs to be kept from the entry or exit position of the door. So this is a example of generative design. So based on, as we change the boundary of the region, the tool will recalculate the entire boundary, and it would again place these all the components in a correct manner. And this is how users can generate various options that they would require, and then they can maybe present it to their customers or within their organization, and then choose best out of these different options that get generated. So here you can see, as we are increasing the boundary or the region, the tool will effectively recalculate the positions, taking into consideration the design rules, the specifications, and so on, and perform the auto layout of the equipments. So then coming back to our webinar presentation, the slides. Few more examples is like one thing which I discussed in the beginning was automating your design checks or your design data, and that's where developing applications like this automated health check, where it would check the model against set of parameters or the conditions that have been defined as a standard for your organization, and then reporting it back to the user for any inconsistencies or deviations within the standards, so that the users can take appropriate actions to rectify or correct those errors. Or as part of process standardization, this tool is developed for Revit server. And with multi-location Revit server implementation, various people start using it in a very different way, like how they are essentially synchronizing with the central model, or how they are doing, whether they are detaching and taking a local copy, how many times they have taken a local copy and maintaining that record. That becomes very difficult task for these users. So that is where we develop this one example of this tool where a consistent workflow is maintained by when users are interacting with Revit server. So the way they are opening the files, or the way they are detaching the files from the local server, or the way they are synchronizing the files back to Revit server. So there is a consistent mechanism in which they are able to do that, so as to avoid any kind of confusion that may arise owing to not following a specific methodology while interacting with Revit server. Or other tools like this object filter and Excel interoperability, where we can filter out the objects based on the category and the properties with specific properties. So I can filter out, let's say, all doors with width of 900 millimeters and so on. And then I can also create this filter sets of the field objects that I have filtered. And then based on that, I can apply various operations to these filters objects that have been created. Or example is Excel interop, where we can filter out the elements and generate an Excel report out of it, which has the element ID, the properties which you have selected. And essentially, it helps in mass updating the properties for all the selected items that we have extracted in Excel. So once we have the Excel, we can simply update the properties and import it back. And that is where the tool would essentially update the properties and the values as per the Excel, and it will do help in doing the mass update as necessary. Or on the right hand bottom position, you can see zoning tool, which would help in creating your construction zones further required for sequencing. So once these construction zones are created, these can then be attached to your 4D tasks, which is your construction task for and then for getting your construction or quantity estimations and for the cost estimations. So these are some of the tools which we have developed for various customers, and these are the tools which actually have been a part of their BIM process and the methodology that was set by them, or we have set for them, understanding their requirements, the scope of the BIM. And one thing is about the integration with BIM 360 or Autodesk Forge or any other third-party systems. So this couple of tools which we developed for various customers or even for our in-house use is like, one is point cloud viewer. So essentially, first step for before even going for conversion from point cloud to 3D model is reviewing the point cloud itself. That's where a web-based point cloud viewer is developed, where users can take a look at point cloud data, based on which they can prepare the estimates, or they can fire any queries if they want. The other tool is essentially doing a side-by-side comparison of your model as well as the point cloud data. So when we are doing as-built model, or when we are converting your point cloud data to 3D model, uh, while checking, we can make use of such tools where we can do side-by-side comparison, and if there are any issues, then those can be reported back. Or integration of BIM 360 for your 5D cost and quantity data. So BIM 360 is being used as a collaboration, where we can share models, where we can share documents and specifications. But for 5D, 6D, there are other systems which are being widely used in the market, and that's where integrating your 5D system, a third-party system, with BIM 360, so that effectively we can integrate them and see the data well, where you will be able to see the model as well as the cost data or the quantity data associated with the model. Or moving on to the 60, which is operations and maintenance, where implementing Forge along with the metadata, which is your specifications, your maintenance cycle, your maintenance records with Forge, so that the owners and operators can easily track what maintenance activities are to be performed, what are the previous maintenance records for various equipments, what was done, the cost associated with it, who are the vendors, and so on. So these are some of the examples of the integrations that we have developed. Uh, the other example is of the design review, where one of the critical stages is essentially sharing the data, your BIM data, the model with various stakeholders, so that they can do they can take a look at early in your design stage. Also, it helps them to do their planning early before the construction or before other activities. And that is where we develop this integration between Autodesk Revit and Autodesk Forge as a cloud-based viewer. And this is where we can publish the Revit model directly to our Autodesk Forge account, and it generates a URL which I can share with various stakeholders. And using simple internet web browsers like Internet Explorer or Chrome, they can view the model. While viewing, they can also add comments or the markups to the model. And then we have a mechanism where we can then synchronize back these comments or markups back in the Revit model. So the designers who are working on the model, they come to know what are the comments or what are the changes that are required as part of the feedback, which they can rectify or make necessary changes and again republish to get it verified or approved. So this typical flow of sharing the model, getting it reviewed, and getting it certified or getting it approved, this is something which can be accomplished using such type of tools, right? And as part of our implementation strategy, what we do is we essentially don't develop small, or rather we don't recommend developing any small tools, but essentially developing a suite of tools where we have a collection of tools which essentially help to uh, help across your BIM process. So whether it is a basic BIM setup, setting up your templates, setting up your model, setting up or importing or browsing families, or whether it is automating your modeling, like one example is this pipe hangers or duct hangers, or whether it is workflow automation like clash categorization or copying of various parameters, or whether it is integration or collaboration, integration with your third-party systems or with BIM 360. That is where we help in creating a suite of tools which can take care of each and every step within your BIM process. And that's where we have helped in doing this for many customers, where as part of our BIM process standardization and implementation methodology, one of the step is to identify which tools can be developed, which will help in automating the process, improving the efficiency and quality, and so on. And on the similar lines, we can develop a similar uh, suite of tools for you, adhering to your BIM project execution methodology or standards for various steps within it, whether be it collaboration, be it modeling automation, or your basic BIM setup, to achieve greater consistency, standardization, implementation of standard workflow for all the users. So this helps in making sure that all the users are following a set of guidelines which are part of the tools that we have developed. And as you work on different projects, it becomes easy to customize these tools to suit your requirements specific to different projects. So this is something which we offer or we do for various customers as part of our BIM process standardization and BIM process automation. Now, I have just last two slides remaining. I'll quickly take those slides and then we can take up questions that are there. So as part of integrated design calculations, one example is where we have integrated MEP design software, which is an external software, not part of Revit, with Revit. So here, one of the thing which this customer was using was they are using a third-party MEP software where they would do the layouting of the equipments. Uh, they would perform the electrical calculations, cost calculations, and then they would replicate that in the Revit model. And that too, while they were doing it in MEP design software, it was simple, kind of a single line diagram kind of arrangement that they were using. That is where we developed this bidirectional interface where we can import the model data, essentially the floor plans, levels, and everything back into the MEP design software, where the designers would do the layouting of the equipments, electrical systems, power systems, and so on, perform calculations, perform cost calculations. And once they have done it, we can import them back into Revit. And when I say import, it's not just importing metadata, but even placing these equipments automatically on each level, each floor as required, setting up the electrical system automatically and updating the properties for cost calculation, electrical performance calculations, and so on. So this is a bidirectional Revit interface that was developed, and this was part of the overall BIM implementation strategy. So starting with creating the families where we know what parameters, how the family is going to be governed, how the parametric families are to be created, and then essentially integrating this with their MEP design software. This is the last slide of my presentation. So as part of uh, process standardization, but this is where the customer was already using 2D platform, and with the entire industry moving to 3D and becoming BIM enabled, they wanted a way by which they can do, instead of doing it in 3D, they wanted to make sure that they can do this in 3D using Revit. So this was developed for a precast company, and the product that they have is these hollow core planks or hollow core slabs, and this they were doing with AutoCAD. And the major hurdle that they were facing was they would get all the architectural models in Revit, and they were required to do it in AutoCAD first, perform the layout, and then again recreate back in Revit, because there is no such tool available in the market. And that's where we developed a product for them to do the automatic layouting of these hollow core planks. So that is where all the cutting of the planks, creating openings within the planks, or placing of these hardware items like your embeds, rebars, dapped ends, and everything happens. And then automatically generation of your piece ticket drawings, piece marks, bill of quantities, and custom schedules and reports. So a very comprehensive application that is developed with them, right from setting up the families for these planks, say, for these different rebars, lifters, and so on, and then developing an application. So transition for with this, they were able to transition from 2D AutoCAD-based 2D mechanism to Revit-based 3D modeling. Right. So this is the last slide of my presentation. I would like to thank you all for attending this today's webinar. And now we can, let me just take a look at the questions that we have. Okay, so we have one question. It is just what is the typical time duration to develop Revit tools? Typical time duration as part of the BIM process standardization and implementation, typically the small tools would take maybe 2 to 3 calendar weeks of development. But when we are talking of developing a suite of tools, that's where, depending upon the number of tools that we are developing, it could range from 2 to 3 calendar months to even it can go up to 8 to 9 calendar months of development. And that's where we do the development in an incremental fashion, where we start with few tools and then keep on adding to it. At the same time, even your BIM specifications are getting ready, your families are getting ready, and that's where we incrementally update your tools library. Okay, one more question. Can you please speak a bit about all can be done in generative design space? Yes, generative design is a relatively a new term that is being discussed, and typically I'll tell you a few test cases of generative design is where, let's say we have your base floor plan ready, and then as a contractor you have to create the floor plan with various configurations. So I can have a 1 bedroom apartment or 2 bedroom apartment, or students location, or student the small apartment specifically for the students. So those kind of when these standard configurations are developed, then essentially arranging these configurations and at the same time making the changes within the configurations across the floor plan, and then presenting it back to various users, or arrangement of your furniture within the apartment space itself, and giving back various options. That's the generative design that is typically being used. Yeah, sorry about that. How much time does it take for a typical process standardization project? Typically, depending upon the BIM scope that you want to implement, and also whether we want to whether we are talking from right from 2D to 6D, or are we talking from 2D to just 3D. Depending upon that, it could be 2 to 3 calendar months of duration, or for a longer scope, which encompasses 2D up to 6D, it can go up to 1+ years of development and implementation process. Okay, I see one more question. From the integration point of view, what are the various platforms tools that you can work on integrating with Revit? Uh, from integration point of view, we have integrated, or we can integrate your Revit or the BIM data with, first of all, your construction planning, construction scheduling softwares. So there are various softwares which are available in the market. Basic being your MS project, where you have a plain task-based project, or on the high end, there are softwares like Oracle Primavera, which is being widely used for construction planning and sequencing. So that is where the integration is possible. Moving on to that, then integration with, of course, BIM 360. It's something which can be done. Uh, then integration with your asset management or facility management system. So for facility management, there's a system called as FM systems. So integrating your Revit data with FM systems. And when we say FM integrating it, FM system already has its own mechanism of doing it. But then if there is more that is required, some custom functionality that is required, then implementing that, or we can develop it right from scratch, where if you have any third-party system, we can integrate your BIM data with the systems. Okay, any other questions? Okay, I think those are the only questions I have received right now. Okay. Okay, I think then we can uh, close this webinar now. I would like to thank you again for attending today's webinar. I hope it gave you insight into how BIM process automation would help in your overall BIM process implementation and your BIM methodology itself. Uh, on in this slide, you can see some links, link to our website or email address marketing@nilsoft.com, where you can, if you would like to know more about our capabilities in BIM, please send us an email, and we would be glad to talk to you again. I would like to thank you again, and see you